Hello everyone, welcome back to the same class of class 8 mathematics chapter 3. We'll be continuing with the previous exercise because in the last class we could not finish one more question. I just want to complete that question. So to begin with, we will go back to the previous exercise, exercise 3.1, question number 7. Question number 7, there are two questions, but I will be solving only one. So both of them are similar. So let's do this figure first. Now, this question is asking us to find x plus y plus z. Now we are supposed to find x plus y plus z. So in the previous class, okay, before we go in here, let's take a quick recap. In the previous class, we have learned about the angle sum property of triangles, quadrilaterals, and all other polygons. Now here, we know that angle sum property of a triangle always states that when all the interior angles are added, all the three interior angles are added, it sums up to 180 degrees. As in the case of a quadrilateral, it sums up to 360 degrees. And for other polygons with sides more than 4, we have to use a special formula which is given as n minus 2 into 180 degree. Now, relating to this, let's go back to the question. Here we see a triangle. A triangle has 3 interior angles. Now, we are supposed to find x plus y plus z. Now, no value has been given, so what we can do is, firstly, we will try to find out the interior angles first. So, let's look at the angles given. This is given as 90 degree, this is given as 30 degree. Here, there is no angle given. So, what we have to do is, let's assume that this is angle 1. Now, the first step that we are going to perform is to find this angle. Now, we know that the angle sum property of a triangle states that all the sum of these interior angles will add up to 180 degrees. So, let's add them up. 30 degree plus angle 1 plus 90 degree should always come as 180 degree. Now, when you add these two, 0 plus 0, 0, 9 plus 3 is 12. Angle 1, 180 degree. Implies angle 1 is equal to 180 degree plus, since this 120 is being shifted to the right, the plus 120 will become minus 120. And finally, you get angle 1 as 60. 0 minus 0, 0, 8 minus 2, 6, 1 minus 1, 0. So we have angle 1 as 60 degree. Now the rest is very simple. We simply have to know linear pairs. Now to find x, let's begin with x. X is a linear pair with this 90 degree. So x plus 90 degree, as stated in the previous class, linear pairs should add up to 180 degree. Now with keeping x as it is and shifting 90 to the plus 90 to the other side, it becomes minus 90. Therefore, you get x as 90 degree. Similarly for y. Y and angle 1, that is 60 now, we know that it is 60. These two are linear pairs. So what we're going to do is we're going to add them together. Y plus 60 degree is equal to 180 degree. So angle y. Therefore, we get angle y as 0, 0, 0, 8, 2, and this. Finally, with z, similar angle z plus 30 degree is equal to 180 degree. Now, we take 30 plus 30 on the other side, it becomes minus 30. Therefore, z is equal to, when you subtract this, you get 150 degree. Now we know the values of x, y, and z. So this has become simple. X plus y plus z will give you, x is 90 degree, y is 120 degree, and z is 150 degree. Now when you add this, 0 plus 0 plus 0 is 0. 5 plus 2 is 7. 7 plus 2 is, 7 plus 9 is 16. We have one remainder, 1 plus 1 plus 1, 3. So the sum of x, y, and z gives 360 degree. With that, we have come to the end of the first exercise. I hope it is clear. All right, before we continue with the next exercise, we'll just have a quick look at the concept. Now, the next thing that we are going to learn is sum of exterior angles of a polygon. Now, sum of exterior angles of a polygon. When we talk about exterior angles, the exterior angles, they look somewhat like this. For instance, here as an example, let's take a pentagon. It has 5 sides, 1, 2, 3, 4, 5. It has 5 sides, and the angles which are marked in green, with green, these are the exterior angles, meaning the angles are outside the figure. When we extend the lines, an angle is formed. So we have 1, 2, 3, 4, 5 angles here. Now, this angle sum property states that when you add the exterior angles, you should get a total of 360 degree, irrespective of the number of angles. Now, with this, we will start with the next exercise. The next exercise is basically very simple. I hope it is clear. Let me repeat it again. The sum of the exterior angles of a polygon will always add up to 360 degree. Please keep that in mind. With that, we will start with a new exercise, exercise 3.2. Question number 1. Here it states find x in the following figures. Now, let me do this first. Now, the exterior angles of a triangle, there are 3 exterior angles of a triangle. The first one given is 125 degree, second is given as 125 degree, and the third we have to find. So as stated earlier, angle sum of exterior angles of a polygon, we'll say using angle sum or property of exterior angles of a polygon, we can see that all these angles are on the exterior. So we're going to add them up. 125 degree plus 125 degree plus x degree is equal to, the total should always come up to 360. Now when you add these two, 5 plus 5, 10, 1 remainder, 2 plus 2, 4, 5, 250 degree plus x degree, 360 degree now. So x will keep as it is, 360 as it is, plus 250. No sign is given means it is positive. Positive means plus. So when you take plus on the other side, it becomes minus. So therefore, we have found x degree, that is 0, 0, 6 minus 5 is 1, 3 minus 2 is 1. So our result is x degree is equal to 110 degree. Similarly, for the second question, if you look in the textbook, page number 44, if you look at the textbook, we have a quadrilateral, meaning pentagon, 1, 2, 3, 4, 5. 5 sides. Now these 5 sides have 5 angles. This square indicates 90 degree. Here square indicates 90 degree. So using this information that is given here, we can calculate the exterior angle in the same manner as we have done for question A. Let's move on to the second question. Now, the second question is, let me write down the question for you. Find the measure of each exterior angle of a regular polygon of 9 sides. Now, here we have to find the measure of exterior angle of a regular polygon which has 9 sides. Now, before we go on to this, we have to know a formula. There is a formula with which we can find the exterior angle of a regular polygon. Now we know that the total sum of exterior angle is always, okay, we'll do that in the next week, is always 360 degree divided by the number of sides. This is the formula that we're going to use. Total sum of exterior angle by number of sides. Meaning this total sum is nothing but 360 degree. And the number of sides is given in the question, it is 9. So when we cancel, 9 into 1 is 9. 9 and 3 not possible, so 9 into 4 is 36 and 0. So here we come to the conclusion that the exterior angles of a polygon with 9 sides, each angle will come to 40 degree each. The second one, 15, will be done in the same manner. I want you to try it at home. It is not difficult at all. You use the same formula, only the calculation part will be different. Question number 3. All right, let's read the question together. How many sides does a regular polygon have if the measure of an exterior angle is 25 or 24 degree? Now this is the same question which has been changed a bit. Now instead of sides, they are giving us exterior angle of the exterior angle of this polygon. Now what we're going to do is we're going to change it to total sum of exterior angles by exterior angle of exterior angle is given and total sum we know. So total sum is 360 degree, becomes like this. So 2, 12, 2, 1, 2, 8, 0, 2, 6, or we can directly go for 6 into 2 is 12, 6 into 3, 2 into 1 is 2, 2 into 15 is 30. So we have come to the conclusion that it has 30 sides. With the same formula, instead of number of sides, we are using now exterior angle of each of the angles. I hope this is clear. This is the same as the previous question. Now, question number 4. How many sides does a regular polygon have if each of its interior angles is 165 degree? Now we don't know how many sides this polygon have. So let's just make a simple drawing, a sketch, simple sketch. We don't know how many sides it has, so I'm just making 4 here. Let us assume that this is 165 degree. Now to find the exterior, see, if I produce all this, exterior angles are formed. Now in the previous class we learned about linear pairs. To find the exterior angle of this particular polygon, we can look at this particular 2 angles given here. 165, this we do not know. Let's mark it as 1. This will be our exterior angle. Now, we know that angle 1 plus 165 degree should give 180 degree. Why? Because they are linear pairs. Linear pairs means when you add up these two, it should come to 180 degree. Now angle 1 will be as it is, 180 minus 165 degree. Therefore angle 1 is equal to, when you subtract this, you get 15. So we know that the exterior angles of each of these external angles are 15 degrees each. Now we know the angle, so it is easy to find. Therefore, we will write down the formula first. Total sum of exterior angles by exterior angle given. So we have 360 degree by 15. So we can use 5, 3, 15, 5, 7, 5, 2, 3, 1, 3, 2, 6, 3, 4, 12. So using this formula, we know that there are 24 sides. 24 sides are there. Each exterior angle is equal to 15 degree. I hope this is clear. So this was question number 4. This was question number 4. Now let's focus on question number 5a. I'll read out the question. Is it possible to have a regular polygon with measure of each exterior angle as 22? Now we have already discussed total sum of exterior angles should be 360. Now to find the number of sides, since they have given each exterior angle as 22 degree, we will divide it by 22. Now let's try to cancel them out. 2, 1, 2, 1, 2, 1, 1 in hand, 2, 8, 16, 0, 11 and 180 is, we cannot proceed any further, any further now, because this is not, 180 is not divisible by 11. So we can conclude that no, it is not possible to have a regular polygon with measure of each exterior angle as 22 degree, because we are not able to cancel out. We cannot divide 360 by 22. So we'll write the answer as question number 5a, no, since 22 is not a divisor of 360 degree. Coming to question number B. Can it be an interior angle of a regular polygon? Why? Can 22 degree be an interior angle of a regular polygon? Why? Now they're asking us why. So what we have to do is we will first calculate each of the exterior angle. We get 180 degree minus internal angle is taken as 22, so we will subtract 180. We get 158. So we know that no, 158 is not a divisor, is not divisible. So we can conclude that no, this cannot be an interior angle because 158 cannot be divided. Right, with that we come to the end of exercise 3.2. Let's have a quick look at a new topic. The new topic is kinds of quadrilaterals and their properties. So, kinds of quadrilaterals. Now, basically there are 6 types of quadrilaterals. Now, before we go there, we have already discussed quadrilaterals means 4 sides. Any closed figure with 4 sides is called a quadrilateral. The first one is called a parallelogram. The second one is called, though this is not in, it should not always be in this order, it can be in any order, rectangle. The next one is square. The next is kite, rhombus, 6 rhombus, and trapezium. Now let's look at these quadrilaterals, how they look. Let me show you. The first one is a parallelogram. The first figure is a parallelogram. It has two parallel, it has opposite sides as parallel, opposite sides are equal, and they have adjacent sides and angles as well. Now, the second one is a rectangle. We all know of these rectangles. They have opposite sides equal, and all the angles, interior angles, are 90 degrees each. Similarly, for square, we have been studying and have been seeing all these squares all the time. This square has all the sides equal, and each angle, interior angle, is 90 degrees. The next, we come to rhombus. Rhombus is similar to, not same, but similar to square. It has all the sides equal. The main speciality is its diagonals, they bisect each other. When you produce a diagonal here, they bisect each other at 90 degrees. Similarly, for kite, they have adjacent sides equal. Adjacent means there's a vertex and the sides on each side of the vertex. These two are called adjacent sides. These two are called adjacent sides. They are equal. These two are equal. These two are equal. Similarly, as in rhombus, if you make diagonals, they will bisect each other, intersect each other at 90 degrees. And the last one is a trapezoid or trapezium. This trapezium has two parallel lines. Either one of these pairs should always be a parallel line. Parallel means when you produce this line, they will never touch each other. If you produce this line, they will eventually come at a point where they will intersect. But these 2 points, they are never going to touch each other. Thus, they are called as parallel lines. Right. Keeping that in mind, we will discuss a little bit about parallelogram. So, parallelogram, henceforth I will be writing like this. It's quite a long name, so I will be writing it in short. Now, parallelogram, when we talk about its angles, parallelogram looks something like this. When we talk about its angles, its opposite angles are always equal. This angle and this angle will be equal. This angle and this angle will be equal. Now, this is the first part. Opposite angles are equal. All right. Now, the second part, adjacent angles are supplementary. Meaning, adjacent meaning they should be on the same line. So, for example, if this is A, B, C, and D, A and B are adjacent, B and C are adjacent, C and D are adjacent, D and A are adjacent. Here we will take A and B. Now, adjacent angles are supplementary. Supplementary means when we add these two, angle A plus angle B, it should give 180 degree. Supplementary. So the sum of these two angles should be 180 degree. Understood? The next is about diagonals. The next is about its diagonals. Angles and diagonals. Now these diagonals are formed like this. AC, diagonal. BD, diagonal. They meet at a point, let's say O. Now the speciality in these diagonals intersecting each other is that AO and CO are equal. BO and DO are equal. That means these diagonals, when they intersect each other, they make these parts equal. That means AO is equal to CO is equal to BO is equal to DO. All the four intersections will become equal. I hope you understand. With this, we will move on to the exercise part. Please turn to page number 50 in your textbook, and let's start with the first question, exercise 3.3. Question number 1. They have given us a figure, something like this. They have marked the intersection as O, A, B, C, D, 4, 2, 3, 1 angles. Now, given a parallelogram ABCD, complete statement along with the definition of property used. Now, they have given us question number 1 as AD. AD, oh sorry, not, yeah, AD. AD. AD is equal to, as we have learned earlier, AD is equal to BC. BC, opposite sides are equal in a parallelogram. In a parallelogram, opposite sides are equal. That means AD is equal to BC. AB will ultimately be equal to CD or DC. Question number 2. Angle DCB is equal to. Angle DCB is equal to this angle. Angle DAB. Because opposite angles are equal. Now, OC is equal to OA because these diagonals intersect and bisect. Sorry, they bisect each other. Bisect means divide into equal parts. So, OC is equal to OA. And finally, angle DAB plus angle CDA is equal to. Now let's look at this. Angle DAB, this angle, plus angle CDA, this angle. These two are adjacent. That means when you add them up, you should get 180 degree. I hope this is clear. Right. Let's move on to the next question. The next question is, consider the following parallelograms. Find the values of the unknowns x, y, z. So a figure is given here. C, B, D. This is A. Now we have to find the values of x, y and z. Now relating to the earlier topic that we have discussed, we know that opposite angles are equal. Now here, angle B and angle D are opposite to each other. Angle A and angle C are opposite to each other. That means angle B and angle D should be equal. So we'll just write angle Y is equal to 100 because opposite angles are equal. Now similarly, we know that, let's take this side. We know that angle Y plus angle Z, adjacent angles, should be 180 degree. Adjacent angles. But we have already found Y, so it will be 100, and Z we have to find. So we'll keep it as it is. Z is equal to 180. This 100 will come on the other side. It will become 100, minus 100. So angle Z is equal to 80 degree. Now we have found that this is also 80 degree. This is 100 degree. Just similar to what we did here, the opposite angles should be equal. So therefore, angle Z is equal to angle X is equal to 80 degree. That means if the opposite of X is Z, if Z is 80, this should also be 80. So we have found out X, Z and Y. We have found out all the angles. So similarly for these questions, you can try some other questions which have been given. We will try to continue with all the sums in the next class, but before we wind up, we'll just I'll just give you a quick idea of how to solve. It has been given as this, Y, 50 degree and X. This is, now here they have given us 50, Y and X. We have to find X, Y and Z. Now 50 and this, let's say this is angle 1. These two are opposite to each other. So angle 1 will be equal to 50. Now if you have already come to know this now. So if you add these two, you should get 180. So what you're going to do is 50 plus X is equal to 180. 50 plus X is equal to 180. Solve it, you will get X. X will be equal to Y. And when you come to this, 50 and Z, they are linear pairs. So 50 plus Z should give you 180. Here, when you solve, you're going to be able to find out Z. So this is how you will be solving this problem. I hope to continue and finish the exercise in the next class. So we'll meet again. Please keep practicing. Whatever we have done so far. Without practice, it's not going to be of much use. Even if I teach you 100 times over here, unless you sit at home and practice, do your work, it will not be helpful for neither you nor me. So I hope that you will all practice and keep up with the studies regularly. So thank you. Until we meet again. See you.